Hi everybody, welcome to another video in trigonometry, section 6.1, inverse trigonometric function. So we have used the inverse trig function a lot, but now we officially learn about those functions. So before we go to those trigonometric function, just review the inverse function in general. So inverse function, the notation is the -1 power here, because we don't say that's f to -1, we say inverse of f. Right. The definition of inverse function is the combination of the function and the inverse give us back to x. Right. F of g of x is equal to x, and g of f of x is equal to x. We have to have both of them. Right. Properties of inverse function. Inverse function require that the function have to be 1 to 1. Mean 1x gives us 1y, and 1y gives back 1x. So the domain and the range of the function, the inverse, we interchange. So pretty much if we have x, if y is a function of f, then y go back to f, y back to x as the f inverse. Because of that, the domain and range interchange. Domain of the function is the range of the inverse, and we interchange those. And one properties of the graph of an inverse function, the graphs of inverse function and the function isometric on the line y equal to x. We'll see that in our definitions later. Now, first let's define the inverse sine function. So when we have the function y equal to sine x, it's not 1 to 1, and therefore the inverse does not exist. Usually every periodic function is not 1 to 1. By the way, let me the 1 to 1 function here to want to be more precise when we define the 1 to 1 function. So 1 to 1 function will pass the horizontal line test. So that is, if we draw a horizontal line and it cut the graph more than one point, then it's not 1 to 1. Of course, the periodic function, because the y value repeats, the y values repeat, so there's more than one y values for, there's one y values for different x values, so it cannot be 1 to 1 function. Right. So if you draw a horizontal line, you cut at 2 points, or actually infinitely number of points, so it's not 1 to 1. Right. So if it's not 1 to 1, then the inverse does not exist. So we have to restrict the function, so it will be 1 to 1. So let's look at the sine function. This is in quadrant 1. From 0 to pi over 2. Of course, in that part is 1 to 1, but it doesn't cover all the negative. So if I choose this part from negative pi over 2 to 0, this is in quadrant 4. If I only limit the x values, in that case, this part of the graph cover all the y values. All the different y values can only take from this point to that point. So if I limit the function only on this domain, then the function is 1 to 1. So as it says here, for the y equal to sine x, if we choose from negative pi over 2 to pi over 2, the function is 1 to 1, and therefore the inverse exists. And the way we define the inverse as follows. the inverse of the function with this domain is called the inverse sine or arcsine. Some other books use arcsine. In this book we just use sine inverse sine to negative 1. Yeah. Some other books we might see they use this, but what we use is sine inverse sine to negative 1, but sine inverse. So when we say y equal to sine inverse of x, we mean sine y is equal to x, and the x in this case will have to be between negative 1 and 1, and the y between negative pi over 2 to pi over 2. Now, so this is the sine x. So let me draw this on the graph. This is y equal to sine x. And for y equal to sine x, the domain, as we said earlier, from negative pi over 2 to pi over 2. And the range from negative 1 to 1. So that is for the sine function. Now the inverse, if we graph it, it will be like this. And that is the graph of y equal to sine inverse of x. And the domain and range for the inverse. As one properties of inverse function, the domain and range of the function and inverse interchange. So the range for the sine x is negative 1 to 1. That will be the domain for the inverse. And the range, the domain of sine x is negative pi over 2 to pi over 2 will be the range of the inverse. So pretty much we switch the domain and range, switch x and y. And one more properties of the function and the inverse, they have the graph that is symmetric on the line y equal to x. Right. And that's what we have here. For the sine inverse, that's what we have. Right, so the key point here is we just need the function to be 1 to 1, the domain and range will interchange, and we have the inverse function. Right, next, how about inverse cosine function? Now inverse cosine would look like this. Y values from negative 1 to 1, and of course periodic function cannot be 1 to 1, so we have to restrict the domain. The way we restrict the domain is this. We always take the first quadrant, and then we choose one more quadrant. Now, if we choose the quadrant 4, like the first example, which if we choose this part, the y values repeated. We do not want that. We want only one values for each x values and one x value for each y values. So in that case, we're not going to choose that. If we want to, we can choose this portion though. In that case, we have all the y values from negative 1 to 1, right? 1x, 1y. However, we're not going to choose this quadrant. Now what we choose is, we choose this quadrant because that's next to it. Quadrant 1, quadrant 2 for cosine. And with that, if we choose from 0 to pi, the function is 1 to 1, and therefore the inverse is this. Right, now the graph. Now the graph of the cosine function that is 1 to 1 in quadrant 1 and 2 is this. So let me write out y equal to cosine of x, and I'll write the domain and range in quadrant 1 and 2, meaning from 0 to pi. The range for cosine is negative 1 to 1. And so that is for the cosine. And the inverse, the graph will be like this. if we graph, because it is symmetric on the line y equal to x. Because when we interchange x and y, we should have symmetric on the line y equal to x. And now we have y equal to cosine inverse of x, and the domain and range we'll interchange this. The domain of the function is the range of the inverse, and the range of the function is the domain of the inverse. So just interchange that. And these are properties of the cosine inverse function. So once again, it's very important that we need to restrict the domain so that the function is one-to-one. And then after that, domain and range interchange, we have the inverse function. Right. Now, same thing for tangent. If we restrict the tangent between negative pi over 2 to pi over 2, so that pretty much still in quadrant 1 and quadrant 4. So this part, quadrant 1 to quadrant 4. So this is what we need. The order will be redundant of the y values. So once again, this in quadrant 4 and quadrant 1, from negative pi over 2 to pi over 2. So if we graph, we have this is tangent. And then domain and range. Domain, we restrict it to be negative pi over 2 to pi over 2. And then the range from negative infinity to infinity. Now we just need to interchange. Right, the range of the function becomes the domain of the inverse, and the range and the domain of the function is the range of the inverse. So just interchange the domain and range. And of course, the graphs will be symmetric on the line y equal to x. And also one important properties in the inverse tangent function, we also have the graph approach to negative pi 2 to pi over 2 when x approaches to infinity. So what we have here is the horizontal asymptotes. So this is horizontal asymptote of pi over 2 and negative pi over y equal to pi over 2 and y equal to negative pi over 2. So the graph will be between those asymptotes. And likewise, we can define the cotangent inverse, cosecant inverse, and secant inverse based on that. So later on we'll put everything on the table, but for now, once again, we only need to restrict the function. So that is one-to-one, and then put that interchange domain and range, we have the inverse strict function. Right, so we put all of that in the table here in a minute. Before that, let's just answer this question. Find the exact values of sine square root 3 over 2. So if we draw a unit circle, square root 3 over 2, the x values, y is sine is the y values, the y values. So this should be in quadrant 1. And then that will correspond to 60 degrees, because sine of 60 degrees is equal to square of 3 over 2. Right. So once again, by definition, if we can check the sine on both sides, for that we have to be very careful with that. But the answer will give us should be in quadrant 1 and quadrant 4 for sine inverse. Right. Now, it's actually easier if we use the calculator. If we use the inverse function, when we use the inverse function, it would be better if we just leave it in degree mode. So for example, sine inverse of square root of 3 divided by 2. We have 60 degrees. Right. But if we write that, it's going to be pi over 3 radian. Right. And if we check pi over 3, the y value is square of 3 over 2. So that's good. Now cosine inverse of negative 1/2. So cosine inverse of negative 1/2. That's 120 degrees, which is 2 pi over 3 radian. Right. Tangent inverse of negative 1, of course. So that's negative 45 degrees, which is of course negative pi over 4. Right. Of course, we can check tangent of negative 1 or negative pi over 4. So here we have the same, x is positive, y is negative, but the value should be the same. Yeah, same x values as y values, only different by the negative sign. Right. Now, so those are easy. Sine inverse, cosine inverse, and tangent inverse. What happens if we have cosecant inverse? Now let's not equal to y, for example, or an angle. Now, by definition, if it is in the domain and range, it's very important. If it is in the domain and range of the values, if it's satisfied, then we will have we take the function on both sides. The cosecant and cosecant kind of cancel out, and we have this. Cosecant equal to 1, negative 1. Now, cosecant is 1 over cosine. And now we can flip both sides. So cosine of y is still negative 1. Yeah, flip both sides. And then we just solve for y. So equal to negative 1. So what is the y value? Of course, we can just do cosine inverse. That is 180 degrees. So pi. Then we just make sure that the definition cosecant inverse the domain for cosecant inverse is from negative pi over 2 to sorry, I was in cruise control there. Cosecant is 1 over sine, so sine equal to negative 1. and that gives us negative pi over 2. Right. Sorry about that. Right. So yeah. So sine inverse, cosine inverse, and tangent inverse, we have the values in the calculator. They know exactly what quadrant it is in, so we don't have to worry about that. But for cosecant, cotangent, and secant, we have to do something like this. Right. Now, if we, those are the nice values, we have the nice angle. But if we have the values that is not as one of those values, then we just use the calculator. For this sine inverse, but this one in radian, so keep this in radian mode. Sine inverse of 0.758. We have that much. 0.86 radian. Right, so that's easy. Now if we have secant, once again, if we don't know what it is, we can make that equal to y, and then we can take secant on both sides. And that cancel out. We have secant, which is 1 over cosine, equal to negative 4. And we can make that a fraction, and we flip both sides. And then we can find the cosine values for that. Give us about 1.8 something. Yeah, so that's what happened when we need to find secant inverse, cotangent inverse, or cosecant inverse. Yeah, we have to write like that. Right. Later on, I said the function and the function inverse does not always cancel like this. But that in the next part of the section. For now, let's summarize all of this, and we'll try to draw the similarity and contrast between this and this definition. Pretty much that's all we have just from the first 2 pages. Let's put all of them together. So the domain and range. For the sine inverse and cotangent inverse, the domain and range of them will be the same. These two will be the same. And that will be all real numbers. I mean, the domain will be negative 1 to 1. Yes, so I will draw them the same. So I just say negative 1 to 1 on the number line. I'll put sine inverse also from negative 1 to 1. Number line between negative 1 and 1. Right. Now, the tangent inverse. The tangent inverse, it's going to be negative infinity to infinity. So the whole number line. I should write this different color. Negative infinity to infinity. For tangent inverse, cotangent inverse also the same thing. the whole number line. Now, secant and cosecant inverse, they will be different than these two. So secant and cosecant inverse, it's easy to describe that on the number line. So for sine and cosine inverse between -1 and 1, secant and cosecant will be outside of -1 and 1. So it's on the outside. And same thing here. So if we want to write that out, -infinity to -1, union with 1 to infinity, -infinity to -1, union with 1 to infinity. Yeah. So those three kinds of domain between -1 and 1, the whole thing for tangent and cotangent inverse, and secant and cosecant will be outside of -1 and 1. So those are the domain. In terms of range, there will only be two kinds. First, the sine inverse. We just say that in quadrant 1 and quadrant 4, right? So that exactly is in quadrant 1 and quadrant 4. -pi/2 to pi/2. So that's for sine. And then for cosine, quadrant 1 and quadrant 2. If we draw that 1 and 4, so it will be here. For cosine inverse, quadrant 1 and 2 be from 0 to pi. Right. Now the tangent. The tangent inverse. If we look at that, it's also in quadrant 1 and quadrant 2 as well. But the difference is no equal sign, because if it is equal to, and there's actually the asymptotes here, so it cannot be equal to. So still in quadrant 1 and quadrant 4, but we have -pi/2 to pi/2 instead. And the graph, the range will be still in quadrant 1 and 2, but without the endpoint. Now, so we have sine and tangent. The one that is reciprocal to sine, 1 over sine, is cosecant, which is also in quadrant 1 and quadrant 4. So that is cosecant. But once again, cosine is 1 over sine, but if sine equal to 0, it's undefined. So we cannot have whenever sine equal to 0, so meaning we cannot have the 0 here. So I will write, this is still in quadrant 1 and quadrant 4, but we're missing the endpoint. I'm missing the midpoint, sorry. So this one missing the endpoints, this one missing the midpoint. So I will write this exactly like this. I'm sorry, not exactly like this, exactly like that. Except there will be missing a point at the middle. Right. Cotangent will be quadrant 1 and quadrant 2, but we do not include the endpoint. And for secant, reciprocal cosine still in quadrant 1 and quadrant 2, but we do not include the midpoint. So we write from 0 to pi over 2, the midpoint union the midpoint to pi. So sine, cosine, we have the full quadrant. Tangent, cotangent, missing the endpoints. Secant, cosecant, missing the midpoint. So those are the summaries of the inverse trigonometric function. So it's not that bad. Now, so along with the definition, we have to know what the domain and range is important. Also from the definition, we have these properties. It says that the sine inverse, we cancel the sine only if it is belong to this domain. So the domain is important. If it is not in this domain, they will not work. It's not equal to the inverse, will not cancel the function. The sine cancel the function, we cancel the inverse if the x is between -1 and 1. So again, if it has to satisfy the domain for the prompt, then it will cancel out. If it's not, it's not equal to. Now, one thing we should note that for everything on this side, though. This pretty much x for every in negative infinity to infinity, so that pretty much define everywhere. So one thing to note that on the function on here, the function will cancel the inverse if it exists. Let me just write the difference between these two. The function cancel the inverse if it exists. Now the interesting part over here, now especially the first two, it may exist because x and cosine, sine, cosine, the domain all real numbers. Pretty much we can put anything into x. It exists, but the answer may not simplify. So even if it exists, I should specify something more precise. What do I mean they? So even it exists, the inverse might not cancel the function. Right. So the difference between these two is the function cancel the inverse if it exists. The other one is it may exist, but it may not cancel. That's what I try to, the point I try to make. So let's look at some example. Sine inverse of sine negative pi over 8. Now, inverse and the function is the negative pi over 8 between negative pi over 2 and pi over 2. The answer is yes. Negative pi over 2 is 90 degrees, and that 90 degrees, 180 divided by 8, that's like 22.5. So yes. So because negative pi over 8 is between negative pi over 2 and pi over 2, that is, it is in the domain of that. Then we cancel out and equal to negative pi over 8. That's easy. Next, cosine inverse of -1. I mean cosine inverse of cosine of 5 pi over 4. So 5 pi over 4, is that belong in this 0 to pi? And the answer is no. So what happens if it is not in that domain? So it exists for sure, yes, but it might not cancel out, and it will not cancel out. So the answer is not going to be 5 pi over 4, because the 5 pi over 4 is not between 0 and pi when we use that properties. So because 5 pi over 4 is bigger than 1 pi, so it is not in this domain. Meaning that they don't cancel. So what can we do instead? So try a calculator, see. Right. Is that in radian mode? It is. Right. So cosine inverse cosine 5 pi over 4. Is that 5 pi over 4? It's not, right? So they're not the same. So certainly they don't cancel, but what do we have instead? So now cosine 5 pi over 4, actually we just go ahead and do that. Cosine 5 pi over 4 cosine 5 pi over 4, what is that? So 5 pi over 4 is a pi, and so this is 5 pi over 4 here. Right, cosine 5 pi over 4 is negative square root of 2 over 2. And then we'll do the cosine inverse of negative square root of 2 over 2. Again, if we do the inverse, it's better to give the answer in degrees, so we know if anything nice and even come out. That's 135 degrees, which is 3 pi over 4. Yeah. Of course, the cosine inverse, the answer must be in quadrant 1 and quadrant 2. So that's what we have. Next, the sine and the sine inverse. Now this is easy. If this is defined, then they will cancel out for sure. So we do just sine inverse of 1/2. Yes, it's 1/2 because 1/2 make this function defined. So yes. Yeah, because this is defined. Because it is in the domain, that's why it is defined. So they just cancel out 1/2 for sure. Next, tangent and tangent inverse of square root of 3. If it is defined, then they will cancel out, and they do cancel out. Yeah. In fact, tangent and tangent inverse will cancel out. So the function will cancel the inverse if it is defined, meaning that the inverse inside have to exist. If it exists, it will cancel out for sure. Next, cosine inverse and cosine pi over 9. Now, the inverse and the function may not cancel out, even though if it exists, it may not cancel out. All we need to check is that the angle is within the domain. So it will cancel out if it is between 0 and pi. between quant 1, quant 2. So it is so yes, so that will cancel out. Right. So pretty much for the inverse and the function have to be in the domain for them to cancel out. If they're not, have to do the math here to determine. Do the inside first and then take the inverse. Right. Now, if we have the function and the inverse, it will be a lot easier if it is defined. So, is cosine of negative 2 defined? And that should be not. Because sine cosine values only between negative 1 and 1. You see, there's an error. So, it's not defined. So, this is undefined. Yeah. So, if we have the function and inverse, just check to see the inverse inside if it is defined or not. If it is defined, then we'll cancel out for sure. If the inverse and the function, that's where we have to check to make sure that it belongs to this criteria. Because if it's not, they might not cancel out, and we might have something else than when they cancel out. Now, so along with the knowing the definition of those inverse trigonometric function, then we have to be able to do this part. This is very important. So sine and cosine inverse. Now, when we do cosine inverse of the trig values, so if we do cosine of something of an angle, that will give us the values. Now, if we do the cosine inverse of the values, will give us back the angle. So if we let theta be the angle inside, so because cosine inverse will give it back the angle, what we can do after that, we can take the cosine on both sides. We do that because cosine and cosine inverse cancel out, and so we have cosine of theta is equal to 4/5, right? That's simple enough, right? Let whatever inside the inverse function, let the inverse function be theta, take whatever the function on both sides to cancel out. Now, the function cancel the inverse if it exists. Of course, when the question asks like this, it has to exist, right? So, they cancel out. Now, since we let the inverse function inside be theta, then this will be just sine of theta, right? That is easy. We know cosine, so be able to find sine. So cosine, the ratio for cosine is x over r, right? Which is, so we can let x equal to 4 and r equal to 5. We can draw a triangle here. X is equal to 4, r is equal to 5, and we can solve for y. So y square is equal to, because 5 square minus 4 square, so 9. So y will be equal to, don't forget there's a plus or minus, square root of 9, which is plus or minus 3, right? And then we do this sine. Now, is that going to be positive 3 or negative 3? Right. But regardless, the ratio for sine is going to be y over r. That's the first thing. So that is plus or minus 3 over 5. Now we just need to determine, is that plus or is that minus? And that should be simple enough. what is the cosine inverse? What is the quadrant for cosine inverse? So let me write this note. Sine of cosine inverse. Now we know cosine inverse will be in quadrant 1 and quadrant 2, right? And sine of anything in quadrant 1 or quadrant 2 is going to be positive. So that's why the answer is going to be positive. Right, I'm curious, does a calculator work if we put that in a calculator? Oh, yes, it does. Yeah. Right, make sure you have the calculator. Actually, it doesn't matter the mode when we do this, but it certainly cancel out. Right, so just like that. Let the inverse inside be an angle. So same thing here. I will let sine inverse. Let theta be the sine inverse of that. And then I can check the sine on both sides, because the function will cancel the inverse if it exists. And of course the question, if they ask, most likely it exists. Of course, if it's not, then we say it does not exist. They will cancel out though. The function cancel the inverse if it exists. Now, what is the ratio for sine? Because ratio for sine is y over 2 and y over r. So from this we can let now this is interesting. Yeah. So of course, if you let x equal to y, that's rather confusing, right? So let's not try x, y, and r. Try something else. If this is in fact have x and y in it, so use different definition. Of course, good thing that we have another definition on the back pocket. Sine is opposite over the hypotenuse. Yeah. So if it is not x, y, and r, and if it is just numbers, it doesn't matter. X, y, and r work just fine. But if there's x in it, it's better to use the opposite and hypotenuse and adjacent. So sine is opposite over hypotenuse. Opposite and hypotenuse. Right. And then we have the Pythagorean identities. Here we can show for the adjacent. So we have that. So we can show for the adjacent is 4 minus x squared and take the square root of that. And then we can say the sine, tangent of sine inverse of x over 2. Sine inverse of x over 2 is just theta. So we just say sine of theta. Tangent of theta. Tangent of theta is what? Opposite over adjacent. So opposite is x over adjacent. So is that positive or negative? Right. Now this might be interesting. Right. So sine inverse is in quadrant 1, quadrant 4. So tangent of quadrant 1 is positive, tangent of quadrant 4 is negative. So which one is that? Now, this problem is not as simple as the previous problem where we said it's going to be positive. This is a little bit more difficult. But now, think about this. If x is positive, let's just do each case. If x is positive, sine inverse of a positive number is going to be in quadrant 1. So that is in quadrant 1. So in quadrant 1, and the tangent is positive in that case. Now if x is negative, that is in quadrant 4. So the tangent is negative. In quadrant 4 is negative. Now, but, there's a but. If x is positive, then it's good. We don't need the plus or minus. If x is negative, again, we don't need the plus or minus, because if there's a minus here, x is negative, divided by negative, it's going to be positive. Right. So the answer, tangent. So in that case, we take a positive, because I said if x is negative, the whole thing is going to be, tangent is going to be negative, right? But since x is already negative, we don't need an extra negative at the bottom. That could be wrong. If there's a minus at the bottom, when x is negative, the result is positive, which is not the case. The case is when x negative, tangent is negative. When x positive, tangent is positive. Because of that, we don't need the sign plus or minus here. If it's positive, the whole tangent is negative, positive. If x is negative, the tangent is negative. So the sign will be the same. So we do not need to change the sign. Do not need the plus or minus here. Yeah, so that's a bit tricky that way. Yeah. Now, cosine of the tangent u over 2. So let's just write once again. Wait. Obviously, this is a typo. Right. So I will let the tangent inverse be an angle. And then I can take the tangent on both sides. Function cancel the inverse. So I have tangent equal to u over 2. Now, tangent, the ratio. Now, since this one doesn't have x or y, we can use x and y and r. But you can also use opposite over adjacent. And then we draw the triangle. Opposite, adjacent, and then we solve for the hypotenuse. So opposite square, adjacent square equal to hypotenuse square. So do that, we have u square plus 4. So the hypotenuse is plus or minus square root of u square plus 4. But just like x, y, and r, we can choose r always positive. So in that case, we choose positive because it's only x and y can be negative. R cannot be negative. So in this case, same thing. We choose positive values only. And then we will say it, cosine of tangent inverse of u over 2. Cosine tangent inverse of u over 2 is going to be theta. And cosine is x over r, or adjacent over hypotenuse. Adjacent is 2. Hypotenuse is that. Again, it's going to be positive. Of course, in this case, we actually can reason tangent inverse is in quadrant 1 and quadrant 4. Cosine quadrant 1 and quadrant 4 is going to be positive. So that's all we have. So in this section, it's very important to know the domain and range of the inverse trig function, which can be summarized into a table like this. Domain and range. The domain, we have 3 different types, between -1 and 1, outside of -1 and 1, and the whole number line. In the range, there's 3 kinds: quadrant 1 and quadrant 4, or quadrant 1 and quadrant 2. Tangent and cotangent inverse, there are no endpoints. Secant and cosecant, there are no midpoints. So those are domain and range. And then we need to know the properties of the inverse function. The function can show the inverse if it exists. The inverse might not cancel the function. So the inverse and the function, this is usually the more tricky one. Inverse might not cancel it. Even though if it exists, it might be equal to something, but they don't cancel out. So that's why we have to be more careful on that case. Yeah. So in that case, usually we just do the inside the function first and then try to find the inverse. For this case over here, if the function cancels the inverse, we just check if it exists. That will cancel out. We won't have to worry about that. And we need to be able to do this. Yeah, let the inverse inside be some angle, and then we solve for the broader triangle and solve for the missing parts, put in the ratio, and so that's what we have. So I stop the section here. As always, thank you for watching, and see you in another video in trigonometry.